This question is about the hydrolysis of haloalkanes. Part A. The rate of hydrolysis of a haloalkane depends on the halogen present. State and explain how the halogen in the haloalkane affects the rate of hydrolysis. So, to get the first mark for this question, we need to explain how, in general, bond strength relates to the rate of hydrolysis. So the first point we're going to make is that the weaker the bond is, this means the faster the rate of hydrolysis, because if it's a weak bond, it's going to require less energy to break, and so the rate of hydrolysis will be faster. And then to get the second mark, you need to compare this to a carbon-halogen bond, like two of them, compare them. So, for example, we can have a carbon-fluorine bond, and this is going to be hydrolyzed the slowest out of the halogens, and then you've got carbon-bromine is hydrolyzed slower than carbon-iodine. So this is your second mark. Part B. Chlorocyclohexane is hydrolyzed with aqueous sodium hydroxide. Outline the mechanism for this reaction. Show curly arrows, relevant dipoles, and the products. So in this question, we have a haloalkane reacting with sodium hydroxide. So the type of mechanism we have is called a nucleophilic substitution reaction. So this is one of the mechanisms you just need to know. So we're going to run through the different curly arrows that you need to have, and this is just a set curly arrow thing that you can repeat on every nucleophilic substitution reaction you come across in A-level chemistry. So firstly, on the halogen, so on the chlorine, we're going to have a delta negative, and on the carbon we will have a delta positive. So this is on the carbon halogen bond. And in sodium hydroxide, the nucleophile is our OH minus, which is going to have a lone pair on the oxygen. This lone pair is going to be attracted to the delta positive region, so the delta positive carbon, because negative electrons attract to the delta positive, and then these electrons are going to kick off the chlorine. So that means our products are going to be a Cl minus, and then instead of having our haloalkane bond, we're going to have an alcohol group. So these are our two products that we're going to form in this reaction. So to get the 3 marks for this question, you get a mark for having the correct dipoles, a mark for having the correct curly arrows, and then a mark for having the correct products. Part C. A student hydrolyzes a haloalkane E using the following method. 0.01 moles of a haloalkane E is refluxed with excess NaOH to form a reaction mixture containing an organic product F. The reaction mixture is neutralized with dilute nitric acid. Excess AgNO3 aqueous is added to the reaction mixture. 1.88 grams of a precipitate G forms. Organic product F has a molar mass of 74.0 grams per mole and has a chiral carbon atom. Part 1. Draw a labelled diagram to show how the student would carry out the hydrolysis of haloalkane E. So the labelled diagram that they want is a reflux diagram. So here I've got a round bottom flask connected to a condenser. So this is what you're going to have to draw in this question. And then we need to add some labels. So at the bottom, we have our round bottom flask. This is also called a pear-shaped flask. Either is acceptable in this question. And attached we have a condenser. So we can add these 2 labels. And with reflux, what you're doing is you're heating. So you're going to heat the round bottom flask. And then you need to describe how the flow of water works in the condenser. So water comes in at the bottom and comes out at the top because you fill it up from the bottom. And then it rises and it comes out at the top, and this keeps a nice flow of cold water coming through the condenser. And this means that your vapours can then get cooled down, and then drop back into the round bottom flask. To get the 2 marks for this question, you get a mark for your diagram, and then you get a mark for your labels. Part 2. Analyse the information to identify E, F and G. Show your working. Let's start by working out G. So G is formed when you're adding silver nitrate to a reaction mixture and you're forming a precipitate. So this is a test for a halogen, and depending on the different colours of the precipitates, a different halogen will form. So we know that we're going to have silver and a halogen as our precipitate G. So what we can do is we can work out the halogen. So we can use the mass of the precipitate formed and the moles of the haloalkane, because it's going to be the same number of moles in our silver precipitate. So using the equation triangle of mass divided by relative formula mass times moles. So this is going to be 1.88 divided by 0.01. And this gives us 188 grams per mole. So this is the relative formula mass of precipitate G. So to work out what the halogen is, we need to do 188 minus 107.9. This is the relative formula mass of silver. So that gives us 80.1, which means that we've got bromine present, because this is the relative formula mass of bromine. So therefore we've got a bromine ion with a silver plus ion. So G is equal to AgBr. So in this question we are reacting a haloalkane with NaOH. So this is another nucleophilic substitution reaction. So in a nucleophilic substitution reaction, you have a haloalkane and you turn it into an alcohol. So this means that organic product F is going to be an alcohol, and it's going to replace the halogen that's in E. So if we work out the molar mass, or look at the molar mass of F, this is going to be a 4-carbon backbone. So we're going to have CH3 connected to a carbon, carbon, CH3. We're going to have 2 hydrogens here, and then a hydrogen here with an OH. Because this has the relative formula mass, if we do 12 times 4, so that's the carbons, plus 9 plus 16 plus 1. So the 9 is all the hydrogens, and then the 16 is the oxygen, and then the 1 is the hydrogen in the OH. And this equals 74. So that means this is F. And we can name this as butan-2-ol. So then if we look at E, well, E is when we are replacing the OH with our halogen, and we worked out in the first bit that our halogen is bromine. So E is going to be the same carbon backbone, so 4 carbons, and then we're going to have 2 hydrogens, hydrogen here, and then a bromine for E. For this question, to get your 3 marks, you get a mark for identifying each compound correctly. So a mark for E, a mark for F, and a mark for G.